What's up, guys? We're back. Another problem, another day, or problems. Um, yeah, this week will be a little bit of a shorter week as well. Usually I'm doing stuff on the weekend, so I'm not really at my computer on the weekend, so I'll try and make videos Monday through Friday, or do some coding Monday through Friday, sometimes Monday through Thursday. But this week will be a shorter week just because it's Thanksgiving, so we got some stuff going on, and yeah, so I feel like we're making decent progress though. I mean, like day 13, day 14, I'm really starting to understand the patterns and really trying to. It's just, again, a little bit of issues with syntax and stuff like that, but hey, the more we do it, the better it's going to be. But, yeah. Shout out to the last video. It actually did pretty well, so I'm, happy about that. That's pretty cool. There's some people watching and following along, so that's pretty awesome. I'll definitely get back to some of the comments on that video, but yeah, let's get into it for this day. So we always begin with the planet of the day. It's been a little while since I've done this, so let's get it on the other monitor. I think our last one was Palace, so now we're at Juno. No idea what this is, but yeah, Juno. Oh, like a show or something. Juno planet. Okay, it's another asteroid. Seems like. Okay, yeah. Minor planet designation. There's a large asteroid in the asteroid belt. Juno was the third asteroid discovered in 1984 by German astronomer Carl Hardy. It's one of the 20 largest asteroids and one of the two largest stony S-type asteroids, along with 15 on it. It is estimated to contain 1% of the total mass of the asteroid belt. Cool. Maybe we can get a little bit more images. Oh. Nope. Does not work. Nope. Well, here's Palace from the other day. You can see how I have barely even been on my computer, but yeah, seems like we're just getting like Jupiter here or something, but yeah, I guess that's our planet. That was kind of a shitty one, but hopefully we get a better one tomorrow. Yeah, so I think where we left off last week, we were revisiting some problems. So again, I'm really trying to understand those patterns and stuff like that, especially in Leetcode. I feel like a lot of it is mainly pattern based. And again, sorry, I'm just opening up my other computer over here so I can see something. I found this other cool list I kind of wanted to check out. But yeah, so again, we were talking about patterns. I am getting familiar with the patterns. Again, from last video, I want to try and master these 7 before I kind of move on anywhere else. But yeah. So I think the goal is for this episode is I think we got to top key frequent elements, so we're gonna probably go through all of these here. Hopefully that shouldn't take a lot of time. And then maybe we can just in this other one over here, we can maybe throw in one that we haven't looked at before and just try and reinforce the knowledge. We will be going back to the daily question of the day soon. I just kind of want to get that foundation, keep going. For this one, again, we're in no rush. We're kind of just doing this out of, just for fun, just some problem solving stuff. So we're only, trying to get better and things like that and just try to understand better. So, yeah. I did look at the question of the day, this one here. It is a hard problem. But we might come back to that. I think it is a little bit kind of more on the easy scale of hard problems, to be honest. I guess we can kind of look at some of the problems that let's see what I missed over the weekend. See, again, it's a lot of matrix problems. And I really struggle with these sort of problems, so you know, well, this one was a binary search one, right? No, sliding window. Oh, maybe I'll share this one. Okay, but yeah, maybe it might take a little bit of a break while it's a matrix. I kind of want to focus on my own matrix problems, like kind of start from the beginning and get a good understanding before I kind of get into those, because those are tough for me to kind of wrap my head around. But yeah, let's get straight into it. So, oh yeah, if you guys want to follow me on GitHub, I'd appreciate that. I don't know. I just have my kind of stuff I'm working on, just my website, and that's still kind of in progress right now. I also post some of the Leetcode solutions on there that I go through, so you know, just keep track and keep my GitHub active. I'm also working on the startup ideas, so you know, again, that's in very early stages. I literally just, you know, installed everything for it on the computer that I'm going to be using, so very early stages. But yeah, just follow it, man. I'd appreciate if you guys follow it, you know, just follow along with my journey and everything. So, but yeah. Okay, let's get into it now. So let's go. I think we're up to this one, encode and decode. Again, we solved this one. It was, you know, maybe, oh my gosh. Okay, well, this is a premium mod, so we haven't solved that one, but that's okay. Let's go back. Product of array except self. Nice. Okay. Arrange array nums, return an array answer such that answer I is equal to the product of all elements of nums except nums I. Runs all of n time without using the division operation. Okay. Well, obviously, if we didn't have that O of n runtime, obviously the brute force solution here would just be a double for loop. Yeah. I'm trying to think. I did solve this one, so I'm trying to think kind of the way we kind of want to approach this problem. Can you solve this problem in O of 1 extra space complexity? I remember there being a little trick on this one, but I don't exactly remember. Let's take a look at the hints. Think about how you can efficiently utilize prefix. Man, I cannot remember how I did this, honestly. Like, how do we solve this one? Movement time. Man, honestly, I cannot remember what the optimal solution is. Product of... Such a stupid question. Okay, so he says here, how the fuck does anyone expect you to look at this problem and be like, ah, yes, very obvious. You should create two arrays, fill one with the products to the left and the other with the products to the right, and then multiply them together without seeing it beforehand. I'm still not really 100% sure how to do that. Let's just take a look here. We got 1, 2, 3, 4. So create an array. See, but I'm thinking here, can't we just extend this array? Right? Because then we're kind of having it, and we only loop through every 3 numbers. Right? That's kind of how I'm thinking about looking at this. I guess this might be the O of 1 solution. Instead of making 2 separate arrays, I don't know. But we start here at 1, we loop through, get all of them, change this number, loop forward, and then I guess we just create, well actually that wouldn't be O of 1 actually technically, because we're creating a new one. I think O of 1 is if you, O of 1 would be if you do everything in the singular array. I think that would be O of 1. This would maybe be like O of 2, I don't know, O of n. I'm not really too sure. I'm not really 100% sure of space complexity and stuff like that, but kind of have a rough idea. But I think that's the way we're going to approach this problem. We're going to extend this array, we're going to double it, and then we're going to loop through, change this number, loop through, change this number, loop through, 1, 2, 3, change this number, loop through, 1, 2, 3, change this number. And then we're gonna, I'm not really 100% sure how to do this exactly, but we're gonna return these 4 numbers. Or put them in a new array and return these 4 numbers. That's what I'm thinking. Yeah. So I think that's how we're gonna approach this problem. So let's define our array. How do I copy all these numbers in the array? Let's figure that out. Copy numbers in from array to new array Python. How do we do that? I have no idea. Like a better way. Probably asking ChatGPT is probably a better way. How to copy an array to another array Python, and then copy again to the same array. I don't know. Okay. I knew it was there was a copy method. Let's do get array is equal to copy nums. Does that work? I'm not sure. That does not work. Hmm. Again, I struggle with the syntax. I'm not sure. Okay, so she's working this. No, I just want to see the copy method, not everything else, dude. For. Oh my god, dude, I don't want to. Module object is not callable. Okay. Array is equal to that. Array equal to copy. Nice. Does that make it any better? Thought to declare it first. Oh, I don't know. Okay, what about, apparently I can directly copy using slicing. Let's see if that works. I am not sure if it does. Okay, nice. Okay, that worked. Now how do I slice it twice? Okay. Okay. Interesting. Well, that's a cool thing to know. There we go. Okay. We got a gun. Okay, so we double our array size here. So now we want to loop through our numbers. So for I in go through the length of the array. And so starting here, we want to loop every 3 values. So how we do that? I want to loop iterate each value with 3 values and see for loop with slicing. Okay, so apparently we can slice. That's cool. And then we can take the sum. No, not secular array. We're called array I plus 3. Sums dot append. Let's just print the sum just to see if it worked, because I don't really know. Oh shit, we probably want to. It can't be called sum. Per sum. Oh shit. Print cursor. std out for. I think this is including itself. If that makes sense. We've got 1, 2. I mean, technically, if it added these numbers, wouldn't it be? We'd be looking for 6, but here we're looking for 9. So I don't know how we got 4. Oh, I guess. Maybe it's redoing. It's looping through. That's why we got something different. I guess that's a good idea. We can create an array. Let's store our sums temporarily so then we can just print it. Sum array. So here's starting from I. We want to start from I plus 1 to I plus 4. Then we want to add it to sum dot. No, sorry, we need to reference the array first. Sum array dot append sum. Okay. Dogs barking outside. Loud as hell. Oh, got another email. Oh, doesn't matter. Okay. What do we get here? 9876974. Okay. So that did work. Wait, so how are we getting oh, we're doing something right. How do we get 24? Wait, what? How do we get 24? I'm confused how we get 24. Oh, the product we're timesing, not adding. Oh, shit. 2 times 3 is 6, 6, 4, 6, 12, 18, 20. Okay. Okay. I wonder if there's a product. No, there can't be. Okay. Doing product. Okay, let's see how we do the product. Okay. Saying here that we need to have just a basic variable times from 1. How we got a double for loop here, so it's n squared now, so it's not going to pass. Okay, I'm gonna try and do this like a super weird way. So we're gonna need the length of the array. So let's store the length. The length is equal to the length of nums. We're gonna loop through this array. We're gonna have a count. So our count is equal to 0. We're going to start from... No, this won't work. I plus 1. It's not going to work. Oh, it's going to work, because you're going to need another for loop. It won't work. Trying to think. Is this problem even solvable with this? Yeah, it is. Okay, yes. Can you solve using a circular array, which may not be the most efficient way. And time using prefix and suffix support technique. However, if you want to explore the circular array, then here's how it could work. So I don't think circular array will be... It's not going to be all van. Yeah, this is the way... Damn. Well, that sucks. I guess we can just start from... Time I plus 1, are we going to... I plus 1... I plus the... Why is it I... Here on the product times the yeah, that's right. And I guess we just, well, yeah, we want to append the append product. I guess we just want to. Shit, we don't even have our result array, we didn't even declare that. So this is obviously going to be an n-squared approach. Associated with a value. That's equal to 1. Should we do that inside the loop? Whoops. Inside the loop. List index out of range. What? Is it minus? No, it's plus. Oh shit. We want the length to be array, not the other one over here. Why the hell is it out of range, man? Why is this out of range? Why is this out of range? I'm not sure. Hell, dude, it's telling me to do I plus 1 plus the length minus 1, but how does that make any difference? Does it? What? Dude. Find range length array. Product norm for J in range I plus 1. Okay, this one we only want to iterate over the original length. That makes sense. I don't understand why it's missing out on this one value over here. Like, it must be something to do with this one. I plus 1 length. Now they've got a while loop in here. God Yeah, you know what? Maybe we shouldn't even continue doing this. Because, I mean, bro, this is n squared anyway. So what's the point of even, like, trying to figure this out to work? Like... Yeah, this is stupid, man. Let's just take a look at the optimal solution. Using the division operator. Alright, we're just going to try and do it this way, the optimal way. I guess this pattern... I don't know what this pattern's called. I don't know what this pattern is called, dude. Yeah, I'm not sure. This be called something. Okay. Let's get rid of this. Okay. The optimal solution, we use a left product array to store the commutative product of all the elements to the left of each index. Use a right product array. Okay. Product, left underscore product. I guess we want to initialize our array to... I think that adds all the zeros, I think. Initialize right and left product. Oh man, sometimes thinking too hard on these problems, man. Like, okay. Oh. Ow. Man, I'm so tired from playing tennis the other day. Jeez. Okay, we don't need to initialize it to be an array. That's interesting. Okay. So y in range length and our nums. Okay, we want to add all the products to the right. So I'm trying to think how we want to do this. Two, three, four. Start here. I guess we just want to loop through for I and range like nums. Right underscore. I hate underscores, man. I think they look so bad. Like, right product. Okay, but where are we storing this, dude? I'm confused. I guess actually we don't even need to initialize them, right? Just put it in, and then I guess we want to start at I+1 as well, no? Right dot append. Man, this shit's pissed me off. Oh! Oh, man. Right dot append, right product. That's gonna be outside the loop, right? Just like variable I, where is on sushi? Bro, what? It's just a normal loop, isn't it? Like, okay. Okay, I don't understand. Oh my gosh, dude. That's so much smarter, bro. Oh my gosh. So this is our result array. I just don't understand how this is looping through left. It seems like it's the opposite way around. Let's the product is equal to 1. This is what they have, right? That is equal to result is equal to left. Dude, I think I'm gonna have to watch the video. Makes me angry that I gotta watch the video.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve product of array except itself. So this is another problem from the blind 75 list. As you can see, for this output array nums returning 1, the multiplication, the product of every other value. So for these three values, the product would be 2 times 3 times 4. That's going to be 24. So for the first value in the output, we're going to put 24. Similarly, for the second value, we want to multiply every value in nums except for this value. So that's going to be 1 times 3 times 4. That's going to be 12. So the second value in the output array is going to be 12. Now, the hard part about this problem is basically the restrictions that they give us. So we have to solve this problem in big O of n time, and we have to do it without using the division operator. It would be really easy if we could use the division operator, because what we could basically do is take the product of all of these values, and we know that would basically be 24. So if we wanted the first value, so if we wanted 24, we would take this total product and divide it by 1, right? That would give us 24. If we wanted what the second value would be, we would take the entire product, 24, which would be all of this, and then divide it by 2, which would give us 12, which would be over here, right? Because the division is basically taking the entire product of the entire thing without multiplying by this. Dividing this would do exactly that. But we are not allowed to use the division operator. So if we wanted the product of every value in here except the 3, one way we can break it down is basically get the product of every value before 3 in the input array and get the product of every value after 3 in the array, and then multiply these two values together, and then that's going to give us the value that we would want to put in this position in our result. So it would be helpful for us if we want to do that for every single value in the input array, if we basically just compute the prefix product for every single position in the input array, right? And then put it in a prefix array. And since we're also going to be wanting the product of values after, it would also be helpful if we computed the postfix product of every single position in the entire input array, right? And we can compute both of these in big O of n time. It's a pretty simple algorithm, right? We'd basically start at the first position. Okay, this is going to be 1. So if we're adding this value, we're just going to take the previous value and multiply it by 2. So this is going to be 2. Similarly, we're going to take 2, multiply it by 3, we're going to get 6 here. 4, multiply it by 6, we're going to get 24 here. And for postfix, we're basically going to do the exact same thing and do it in reverse order. So here we would get 4, here we would get 3 times 4, here we would get 2 times 12, and then...
See, I was thinking about it a different way. I was thinking about like the numbers there, so we have to skip over that number, and I was like, what?
Here we just get 1 times 24, which is just going to still be 24. Now,
How do we, when we move backwards, we go length nums minus 1, minus 1, minus 1. Yeah, right underscore product. Okay. Okay, so what this is doing, we're starting in 4i and range length nums. So we start here. Result I is equal to left product. So this result is equal to 1. Left product times are equal to nums I. Left product nums I is 1, so it would just be 1. That'll be our first iteration. Now second, we'll go here. We have left product result I is equal to left product. 1. Left product. Bro, I'm so tired. Oh my gosh. I think it'll be 1 again. This is a crazy brain. Okay, we're gonna do our result array. Is equal to our left product is 1. Okay, it's equal to 1. So then we add 1. Left product times equal to nums I. Here it's 1 again. So we get rid of this. We have another 1. Then we go through. Okay, result I is equal to left product. Our left product is 1. Then our left product times equal to nums I. And we get 2. We have 2 now. We put in 2. We do left product times equal to 3. 6. We make this 6. We do 4, which is 24. You can get rid of this. And we go through. We move through our nums from backwards, right? So now we'll do our right product. Our right product is equal to result I times equal to right product. So starting here, our right product is 4, so 4 times 1. Our res ray, this is 4. And then nums I times right product. 4 be 4, right? Yeah, right product times nums I. We got 2 here, so we put 8. Put 8. Then our right product becomes 8. Then we do 6 times 2, which is 12. 12, get rid of that. Then this goes to 12. And then we do 12. Sorry, where are we at? 24. 24 times 1 is 24. Dude. We have 4, 8, 12. Well, I did something wrong. This is not 56.
Now for every single values, for example 1, we would want the prefix of every value before it. Now since there are no values before it, we can just say, okay, the prefix for that is just going to be a default value of 1 to keep it neutral. And so we'd also want the postfix of every value that comes after it. We can get that in the position to the right of 1. So we'd want to multiply those together, so 1 times 24. So in the output for this, we would get 24. That makes sense because if you multiply all these together...
Oh, that's why I didn't get it, because I didn't loop from the other way. I started from here. If I looped from here, it would have been 24, 12, 8, 6. That's stupid of me, but... Oh, man, that was confusing. Jeez. Okay. Took an hour. Nice. Okay. Let's go to a different problem. Okay, so obviously my approach to the circular array was still O of n squared. That was stupid of me, but hey, we're learning. We're learning. It's okay. Okay. Oh man. Let's do longest consecutive sequence. I'm gonna skip Sudoku because I don't want to do any grids. So. Okay, another problem that has to be done in O of n time. Okay. Okay, so what we're gonna do is we're gonna start. I think what we're gonna do is we're gonna start with the brute force solution. So I'm gonna solve the brute force solution, which won't be O of n, it'll be n squared. Oh. Thought it has to be in a row. Well, that's weird. Okay, longest consecutive. Okay, so it's like... Yeah, okay. So what we're going to do is we're going to solve the brute force, so... Sorted nums is equal to nums dot sorted. I think that's how we do it. Okay. Let's just print sorted nums to make sure. Bro. Okay, so we sort it, then we do for I in nums. For I in range length nums. For J in range length nums. Then we want yes, do we have to do this or can we just do an if? If I equal I plus 1. I guess we can make a count here. So I count at 0. I guess if nums I it's gonna live through like that. I guess we don't need to do that. We can just if nums I no way this works, bro. Like I think it's because this isn't. Dude, like, bro, what? We can just change this, but it doesn't really matter, but it's for visibility. Let's change it. Oh man, I'm dying today. Oh my gosh. Oh, so tired, man. So tired. Let's give it a look. Bro, fuck this, dude. This is not gonna work. gosh, we're doing it the wrong way around, bro. Bro, am I tripping? Like, just fix my syntax, bro, please. Bro, I'm getting a huge headache, dude. Oh my gosh. Num nums 10 0. That's actually a good. That's fucking really smart. You gotta. I don't understand. I don't understand why I have to return. I have to return. Okay. Interesting. Yes, this is a login and login approach. Oh, that didn't work. Nice, dude. Nice, bro. Yeah, that's what I thought. That won't solve it all, I don't think. Oh, it does. Okay, use a set, bro. What? Well, that is actually a smart way of doing it. Gets rid of the duplicates. So I guess, I mean, you can also do it an n squared way. Sorry guys, I haven't been speaking much. I've just been so tired and so yeah, just so tired, man. I don't know, my body has like for num and nums, co-num is equal to num. Okay. Okay, since we're done with this one, let's move to a stack. I did do valid parentheses earlier today. I guess we'll just try and fit in 2 more. I mean, hopefully these ones shouldn't be too bad. I mean, I'm gonna probably take a nap and then do some homework, but I'll just do min stack. I remember this one. I think it is pretty straightforward. I think we're just implementing stuff. Self.stack is equal to this. If you want to push an element, self.stack.append. I don't even know. Get the top element. Self.stack. Think back. Get min. Self.stack.top. Get min. How do we get min? How to get min stack Python. I'm actually not sure how to do that. I've got no idea off the top of my head. Oh shit, I think we should be returning. Return. I think that one needs a return. I think it's what, min? I think there's a min function, to be honest. I'm not sure off the top of my head, man. I don't know how to do the min. Let's just see if this works. Pen val, I think, right? Yeah, that worked. Do I need to do val for everything else? I don't know. Soft popped up val. dude. I don't know how to get them in. Bro, I generally don't know how to get them in. Bro, how do you get them in, bro? Bro, how do you get them in, bro? Bro. I don't know how to get them in. I'm gonna go back. I can't. Oh, doesn't even give me the answer, bro. Oh shit, man. Bro. I have to check. I don't know how to get the min, dude. I cannot remember. Give me a Python, bro. What is min? No, bro. There's a way easier way than that. What? How did I do it? Min self.stack. How do I get back to my code? Nice. It's just min. Bro, mine's so slow. Self.min list. I don't know if that's bad. I don't know. I mean, oh my leg, bro. Nice. Okay. We'll just move on. So I guess the last problem we'll look at today, the Polish notation. Polish notation. We'll actually do one more problem after this. I'll do just one that I haven't looked at. I'll just pick one off the internet that has a stack or something. Let's take a look at this. The valid. So 0, there will not be any division by 0. The input. Okay. 2, 1. Okay. Range. I do remember we got to iterate over every number now. If tokens I dot is digit. Is that a thing, dude? You know that was a method. Is digit. Just do fine tokens. Fine tokens. Then we can just do I dot is digit. Then we want to add add to our stack. Oh shit. Stack is equal to do stack dot append I. Just see if that works. I don't know. Okay. I think that worked. Also, if I is equal to plus, or I is equal to a negative, or I is equal to a times equal to a slash, then because I know in Polish notation, if you see a number and you add it to the stack, but if you see this, then you pop the last two numbers and you add them, multiply, division, whatever them together and add it back to the stack. We're gonna have to do different if statements for this, I think. Yeah. We don't even need an is digit. We can probably just do a bunch of ifs. Plus, minus, times this. And take the next two numbers. The plus, then we want to... First is equal to stack dot pop. Second is equal to stack dot pop. And we want to do first plus second is equal to... Oh, sorry. And is equal to first plus second. And start... stack dot end ends. Else, I guess we can just keep copying that as just the same thing. Else if it's a minus, then we can just minus them. Else if it's a times, we can just times them together. Else if, oh sorry, divide, can divide them. Does this mean floor? Shit, it's a double. Bruh. Or I have no idea if this is gonna work, but let's see. Okay. I think okay, maybe I think this might be working. I'm not sure. Let's see. So it's no, get rid of this. We want in here, and in here. Okay. 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 Yeah. That's what I was gonna do. Should have done it. So we have an else here. Okay. And we do else. No, we need to keep that. Put this here. So get rid of this crap. Get rid of this crap. Get rid of this crap. Move this. Get rid of this. Move this. Put it here. Boom, 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 boom. Okay. Now we need to make sure that we're doing. We do need to do second over first because second does pop first. So that was first. Second minus first. second plus first. And we want to turn our stack. Turn our stack. It's the top of the stack. These two. Second plus first. Valid syntax. Oh, oh my gosh, bro. Get rid of the colon, dude. Okay. I think we're doing something wrong. I don't think it's taken in the negatives properly. Secondly, I don't know if that's a... Let's ask. I'm asking what's wrong with my solution. I think it could be something to do with the negative. Solution. Is digit. Apparently, so I was right. It's not handling the negative here, right? But apparently this handles the negative, but this here needs to pass as an int. I think I should be good. Nope. Nope, 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 nope. Nope, nope, nope. Dude, I was so close, dude. I was so close. But I don't know. Oh my god, I'm inside the 4, dude. Jesus, dude. There we go. Sometimes it's hard to see that when you're scrolling, dude. Okay. Alright, let's do one more problem. Do one that we haven't seen before. Kind of get our knowledge flowing a little bit. Oh my gosh. Ugh. Good. Then I'm gonna take a nap, eat some food, do some homework. So I am behind on homework. So reverse a string. That's a stack problem. Oh. Let's see if we've done that problem though. I think that sounds familiar. I feel like I've probably done it. Reverse a stack. Sorry, reverse a string. Yeah, it's too easy, bro. I need to know, bro. X greater element. Bro, these are all easy, bro. What the? By path. Okay, let's take a look at this one. Okay, there's a lot to this one, damn. That's the previous parent, right? I should follow these rules. Man, there's so much to this one, bro. Oh my gosh. I was hoping for an easy one. Okay, I guess we have to go through all the rules. A single period dot represents the home directory. A double period dot represents the previous parent directory. That's why we don't have documents. Okay. I in path. I feel like it's always going to start with a stack. Right? I mean... Oh my gosh. He's really been on 2 hours. Oh my gosh. Oh my god. to this. Append I. If I is equal to always begins with a slash. I guess we can just add the slash out the front. Append. Always begins with slash. Right, so we append the slash. I guess find range. Path. We can start at I+1. I guess we want to append that. I guess if I is equal to the alphabet, and Python. Yeah, bro, 100%, dude. Slash. If I in range, I+1. Man, did I pick the like shittiest one, bro? Like, okay, this is a good problem. I do want to do this one, but I'm gonna come back to it just because there's so much to this problem, and I feel like it'll take me like an hour to do it, and I'd rather do something more simple. So I'm actually gonna write down this problem. I just don't feel like programming right now, man. You know, I don't really feel like adding all this. Simplify path. Say it's a stack problem. It is a good problem, I think, but it's just like, bro, so many cases. Like, it's like, I'd rather do something way more simple. I think I found a more simple one that uses a stack. Sorting a stack. Is that what it's called? Sorting a stack? Pancake sorting, bro? What? Bro. How's pancake sorting? Sorting a stack, Leetcode. Bro. Dude, some of these problems are... Just gonna click the stack problem, dude. What's the left topic? Stack. Let's just do an easy problem. Oh, well, there's not many. And mine just had, let's do reverse prefix of word. What? Given a zero-index word and a character CH, reverse the segment of word that starts at index 0 and ends at the index of the first occurrence of CH inclusive. The character CH does not exist and word do nothing. What? I'm confused. Okay, I think I understand. For I in range length word if CH is equal to word I. Do something else. Let's just continue. Alright, I guess we can just. So I guess if it finds it. Well, let's append. Append word I. If we do see it, and so let's do our pointer is equal to I. We'll set a pointer. I guess we've added everything up to that point, but how can we reverse what's currently in the stack? How can you reverse a stack? Headphone. No. Can we just do stack to can we reverse our stack? Stack is equal to this. Stack to how do you reverse the stack, bro? No way you can actually reverse a stack, dude. Return stack. value. How to return a stack as a string. Let's split up. I don't want spaces in between. Okay. What's going on here? I guess you can only reverse it once, so... And can't... Does not equal 0. We decrement count. I don't know if this is gonna work. Oh, there we go. Okay. Well. Thank you guys for watching. I'm gonna go make some food. See you guys tomorrow.